Hello friends, today we would be starting a new chapter which is a very important chapter, that is the laws of motion. It is for 7 marks. The compulsory questions are for 7 marks, and with or if you want to solve the questions from this chapter, then the questions would be for 10 marks. It is a very important chapter, the laws of motion. Now, the branch of physics which deals with motion of a body is mechanics. Now, this mechanics has two parts. One is the static and another is the kinetic. So, statics is, as the name suggests, statics mean which is at rest, je sthir rahe. So, the branch of physics, that is the branch of mechanics, that is statics, deals with the body which is at rest or which is in equilibrium when some forces from outside are acting on the body. Kinetics is the branch which discusses about the body which is in actual motion. Now, this has kinetics branch has two parts. It is separated into kinematics and dynamics. Now, kinematics is a branch which deals with the motion of the body without discussing its cause. म्हणजे कोणत्या कारणाने ती मोशन घडते आहे हे डिस्कस करायचं नाहीये. फक्त ती the body is moving. That is, what is the displacement of the body, or what is the velocity of the body, what is the speed of the body, what is the acceleration of the body. All this regarding the motion of the body is discussed in the part kinematics. And in the part dynamics is discussed. Dynamics मध्ये काय डिस्कस केलेलं आहे तर the body which is moving, which is in motion. So why it has come in the motion? What force was applied upon it so that it started its motion? What is the energy? What is the power? So all these factors, the work done, all these factors are discussed in the part dynamics. So now we would be discussing about the Newton's laws of motion. Actually, these laws are deleted from your syllabus, but still they are very, very important, and we would be requiring its content. We would be, so that you should know the laws for the next part of the chapter. We would be requiring these laws, hence I am discussing the Newton's laws in very, very short. So, Newton's laws of motion, the Newton's first law, it is related to the inertia. It is also a law of inertia. And the statement is, every inanimate object continues in its state of rest or of uniform unaccelerated motion unless and until it is acted upon by some external unbalanced force. बेसिकली हा लॉ आहे इनर्शियाबद्दल. हा सांगतो की प्रत्येका बॉडीकडे इनर्शिया आहे. इनर्शिया इज द टेंडन्सी ऑफ द बॉडी टू मेंटेन इट स्टेट ऑफ रेस्ट ऑर ऑफ युनिफॉर्म मोशन. म्हणजे ती बॉडी जर रेस्टवर असेल तर ती रेस्टवरच राहणार, आणि जर ती मोशनमध्ये असेल तर ती मोशनमध्येच राहण्याचा प्रयत्न करणार. सो सच इनर्शिया इज अन इनहेरंट प्रॉपर्टी ऑफ एव्हरी बॉडी. मी आपण एक्झाम्पल घेऊ. मी जर एक बॉल घेतला आणि तो बॉल मी जमिनीवर असा टाकला. So what will happen if the floor is very rough? It will stop at a very short distance. If the floor is very, very smooth, it will go on moving, and after moving some large distance, it will stop. Now, why this is happening? So that there is a ball thumb. Actually, according to the Newton's first law, the ball should not stop. It should be in its uniform motion. It should continue in its state of uniform motion. बट देर इज अ फ्रिक्शनल फोर्स. तो बॉल जेव्हा त्या फ्लोअरवरून मूव्ह होतो, ॲट दॅट टाईम वेन द बॉल इज इन मूव्हिंग in one direction, there is a frictional force between the ball, the surface of the ball and the floor, which is exerted in exactly opposite direction. आणि हा तो frictional force आहे because, and this frictional force is opposing the motion of the ball, and hence the ball stops after some time. Otherwise, if the frictional force would not have been there, according to Newton's first law of motion, due to the inertia of the ball, it would have moved and moved and moved. So the next, Newton's second law we would be discussing, which is the law related to the change in the momentum. The statement is the rate of change of linear momentum of a rigid body is directly proportional to the applied force and takes place in the direction of the force. Now what I have explained you in the statement form, in words, this is its mathematical form. So the force F and the change in momentum is dp by dt. So P, which is mass, P which is linear momentum, is mass into velocity. So this mass is a constant, so we can take it outside the bracket. So we get m into dv by dt. But what is dv by dt? Change in velocity per unit time is acceleration. And hence m, this dv by dt is a. So this is ma. So we get, from the Newton's second law of motion, we get F is equal to ma. That is, the force is equal to mass into acceleration. So this is the Newton's second law. And the Newton's third law, it is the law of action-reaction, which says that the statement is, to every action there is an equal and opposite reaction. So if I hit by my hand on the board or on the wall, then the wall is all, this is the force of action. मी हाताने भिंतीवर हिट करते आहे और बोर्डवर, if I am hitting on the board or on the wall, so this is action, and the wall is also going to hit my hand, so that is the force of reaction. So to every action there is an equal and opposite reaction, and we all know, due to the Newton's third law, we can send our rockets in the space. The next point is the frame of reference. Now, when we are discussing about motion, a body is moving from one place to the other, we have to give some reference or some frame of reference. Now, a train is moving, a bus is moving, and I am standing on the bus stand. मी बस स्टँडवर उभी आहे आणि तुम्ही बसमध्ये बसलेले आहे. Your bus has started moving. So according to my frame of reference, you are moving. तुम्ही मूव होताय. You are in motion. पण जर मी तुमच्या बरोबर, आपण एका सीटवर बसलेलो असू, समजा बसमध्ये आपण एका सीटवर बसलेले आहे. सो अकॉर्डिंग टू माय फ्रेम ऑफ रेफरन्स यू आर एट रेस्ट. तुम्ही स्थिर आहे माझ्या दृष्टिकोनातून. सो टू नो or describe a motion, you need to define some reference. Such reference is called as the frame of reference. Now, the frame of reference is of two types. One is the inertial frame of reference and another is the non-inertial frame of reference. It is also called as accelerated frame of reference. And this is non-accelerated frame of reference. The frame of reference in which the body is at rest, म्हणजे दोन्ही जी frame of reference आहे ती आणि ती जी body आहे, about the motion of which we are discussing. So supposing with respect to the frame of reference the body is at rest, then it is the inertial frame of reference. With respect to the frame of reference, the body is moving, it is in motion. But how? It is moving with a constant velocity. Then again the frame of reference is a inertial frame of reference or non-accelerated frame of reference. इथे कुठेही बॉडीला ॲक्सिलरेशन नाही आहे. So such frame of reference is a inertial frame of reference. And in this frame of reference, the Newton's laws, all the Newton's laws are obeyed. हे जे न्यूटनचे लॉज आपण डिस्कस केलेले आहेत, they are all obeyed in the inertial frame of reference or non-accelerated frame of reference. Now the next frame of reference is the non-inertial frame of reference. It is also called as accelerated frame of reference. Now how is this frame of reference? The body is moving in accelerated motion. Yeah, according to this frame of reference, when the body is moving in accelerated frame of reference, म्हणजे त्या बॉडीला जर acceleration आहे, then such is a non-inertial frame of reference. म्हणजे बॉडीमध्ये acceleration असेल तर मग ते frame of that is a non-inertial frame of reference or the accelerated frame of reference. ज्या क्षणामध्ये acceleration बॉडीला आहे ती frame of reference non-inertial frame of reference. And the Newton's laws, न्यूटनचे जे नियम आहेत ते non-inertial frame of reference मध्ये Newton's laws are not obeyed in the non-inertial frame of reference. Now, in the next point, we would be discussing about the types of forces. Initially, we would be discussing the fundamental or the real forces, जे निसर्गामधले जे खरे रिअल फोर्सेस आहेत, जे फंडामेंटल फोर्सेस आहेत नेचरमधले, ते आधी आपण डिस्कस करणार आहे. आणि त्याच्यातला सगळ्यात पहिला आणि सगळ्यात महत्त्वाचा दॅट इज द ग्रॅव्हिटेशनल फोर्स. It is an attractive force which is existing between any two point masses. म्हणजे this force, according to the Newton's law of gravitation, न्यूटन या शास्त्रज्ञांनी जो स्टडी करून जो न्यूटन्स लॉ ऑफ ग्रॅव्हिटेशन सांगितलेला आहे. सो अकॉर्डिंग टू दिस न्यूटन्स लॉ ऑफ ग्रॅव्हिटेशन, दिस ग्रॅव्हिटेशनल फोर्स विच इज F इज डायरेक्टली प्रोपोर्शनल टू द प्रोडक्ट ऑफ द मासेस. सपोजिंग हा एक M1 हा मास घेतलेला आहे आपण, M2 हा दुसरा मास घेतलेला आहे, तर ग्रॅव्हिटेशनल फोर्स हा एक्झिस्टिंग कोणामध्ये आहे? कोणत्याही दोन मासेसमध्ये आहे. मग मी पुढे जाऊन असं म्हणू शकते की अख्ख्या ब्रह्मांडामधल्या कोणतेही दोन मासेस कन्सिडर केले तर त्यांच्यामध्ये हा फोर्स एक्झिस्टिंग आहे, ग्रॅव्हिटेशनल फोर्स. सो आपण हा मास कन्सिडर केला M1, दुसरा मास कन्सिडर केला M2. सो धिस M1 इज अट्रॅक्टिंग M2 in the direction of M1 and M2 is attracting M1 in the direction of M2. दोघंही मासेस एकमेकांना अट्रॅक्ट करतायत आणि असा हा अट्रॅक्टिव्ह फोर्स आहे ग्रॅव्हिटेशनल फोर्स. R हे त्यांच्यामधलं डिस्टन्स आहे. सो अकॉर्डिंग टू द न्यूटन्स लॉ ऑफ ग्रॅव्हिटेशन, this gravitational force or the attractive force is directly proportional to the product of their masses. दोन मासेसचा गुणाकार, product of their masses, and it is inversely proportional आहे. कशाला? to the square of the distance between them, r square. जेवढं डिस्टन्स वाढत जातं तेवढा फोर्स कमी होत जातो, कारण हा इन्व्हर्सली प्रपोर्शनल आहे. आणि मासेस जेवढे जास्त आहेत तेवढा हा फोर्स जास्त असतो. सो दिस इज द रिलेशन. प्रपोर्शनलिटीचं जेव्हा आपण इक्वालिटीमध्ये कन्वर्ट करतो, ॲट दॅट टाइम वी हॅव टू टेक अ कॉन्स्टंट. सो हिअर वी आर टेकिंग G, which is the universal gravitational constant G. And the value of this universal gravitational constant G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So such is the force. म्हणजे ब्रह्मांडामधले कोणतेही दोन पार्टिकल्स असतील तर ते एकमेकांना या ग्रॅव्हिटेशनल फोर्सच्या मदतीने अट्रॅक्टच करणार आहे. In our daily life, the gravitational force experienced in our daily life is our weight. We experience the earth is pulling us due to the gravitational force. Now, supposing this is the surface of the earth and the person is standing on the surface of the earth. Now, According to the Newton's law of gravitation, what is the gravitational force which is existing between the person and the earth? दोन्ही एकमेकांना तेवढ्याच फोर्सनी ओढतायत. So the gravitational force is, according to the Newton's law of gravitation, F is equal to G m1 m2 upon r square. Now, the weight is the gravitational force exerted by the earth on the person and by the person on the earth. So the weight. Now weight इथे आपण put up करणार आहे. So this weight W is G. G is the universal gravitation constant. पहिल्या मासच्या जागेवर पहिला जो मास होता m1 आणि दुसरा जो मास होता m2. They are attracted by the force. ह्या पहिल्या मासच्या जागेवर आपण काय टाकतोय? Mass of the earth. Mass of the earth. And दुसऱ्या मासच्या जागेवर आपण काय टाकतोय? Mass of the person. So this is the person here and the earth here. So this is the person, this is the person, and this is the earth. Now, G me, mass of earth into m2, that is the mass of the person, upon, या दोघांच्या मधला distance किती आहे? We take the distance from the center of the earth. So the distance is the radius of the earth, that is RE. So we take RE here. Now, we rearrange. आपण थोडं rearrange केलं आणि लिहिलं W is equal to M GME upon RE square. Now this G universal gravitational constant, as we have discussed just now, the value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. And ME, that is the mass of the earth, is 6 into 10 to the power 24 kg. हे पृथ्वीचं मास आहे आणि पृथ्वीची रेडियस किती आहे? इट इज 6400 किलोमीटर्स इज द रेडियस ऑफ द अर्थ. मग हे तुम्ही घरी कॅल्क्युलेट करून बघा. हे जे मी सांगितलंय, सो 6.67 to 10 to the power minus 11 ME, that is 6 into 10 to the power 24 upon 6400, that is 6400 into 10 to the power 3 चा स्क्वेअर. हे तुम्ही करून पाहिल्यावर तुम्हाला त्याचा आन्सर 9.8 मीटर्स पर सेकंड स्क्वेअर मिळेल. रेडियस जे किलोमीटर्समध्ये आहे ते मीटर्समध्ये कन्व्हर्जन करायचं, सगळ्या त्याच्यामध्ये पुटअप करायच्या व्हॅल्यूज आणि आपल्याला त्यावेळेला आपल्या जीची व्हॅल्यू 9.8 GME upon RE स्क्वेअर ची व्हॅल्यू 9.8 मीटर्स पर सेकंड स्क्वेअर मिळते. त्याला आपण G म्हटलेलं आहे, म्हणजेच आपण ॲक्सेलरेशन ड्यू टू ग्रॅव्हिटी G, जे आपण वेट जे म्हणतो M into G, this G is actually GME upon RE square. So this is our everyday experience. That is the weight, which is the gravitational force exerted by the earth upon us. The gravitational force is unlimited. It is for all the universe. मग तुम्ही म्हणाल की जर तो अख्ख्या ब्रह्मांडामधले कोणतेही दोन पार्टिकल्स एकमेकांना अट्रॅक्ट करतायत ड्यू टू द ग्रॅव्हिटेशनल फोर्स, मग आपल्याला कसं जाणीव होत नाही? वी आर ऑल्सो सम मास. इफ देर इज सपोजिंग अ वॉल इन फ्रंट ऑफ मी, इज इट दॅट आय एम अट्रॅक्टेड टू द वॉल और द वॉल इज अट्रॅक्टेड टू मी? Because we too are also the masses in this universe. The gravitational force which is exerted by body m1 on m2 and by body m2 on m1, F, that is equal to g m1 m2 upon r square. We would consider one example of two sumo wrestlers. खूप strong, खूप healthy, खूप जास्त weight असलेले असे ते wrestlers आहेत, sumo wrestlers आहेत आणि त्यांचं जे मास आहे ते किती किलो वजनाचे? दोन्ही रेसलर्स 300 किलो वजनाचे आहे. मग आता आपण डिस्कस करू की त्या दोन असे हे जे दोन सुमो रेसलर्स समजा आहे 300 kg, बोथ आर हॅव्हिंग 300 kg मास. सो both are having 300 kg mass. Now we will understand how much is the pull or gravitational pull in between the both of them. आणि जर हे सुमो रेसलर्स एकमेकांपासून फक्त अर्ध्या मीटरवर उभे आहे, म्हणजे द डिस्टन्स वी नो दॅट द मोर द डिस्टन्स द लेस द फोर्स. पण आता डिस्टन्सही आपण खूप कमी केलेला आहे. सो आपण इथे व्हॅल्यूज पुटअप करू. F इज इक्वल टू G ची व्हॅल्यू पुटअप करू. युनिव्हर्सल ग्रॅव्हिटेशनल कॉन्स्टंट 6.67 इंटू 10 to the power -11. M1 पहिल्या सुमो रेस्लरचं मास 300 kg, दुसऱ्या सुमो रेस्लरचं मास 300 kg आणि त्यांच्यामधला जो डिस्टन्स आहे तो 0.5 मीटर हा डिस्टन्स आहे. सो आपण हे कॅल्क्युलेट केलं तर आपल्याला असं दिसतं. द आन्सर वी गेट इज very small, that is we get 24 into 10 to the power -6 Newton. When we calculate this, the answer is 24 into 10 to the power -6 Newton, that is 24 micronewton. That is the gravitational force which is existing between the two very strong persons who have 300 kg weight. So the gravitational force is existing, but how much it is existing? It is very small, and the force is 24 into 10 to the power, it is nearly 24 micronewton. आणि हेच जर आपण अर्थ त्यांच्यावर किती ग्रॅव्हिटेशनल फोर्स एक्झर्ट करते किंवा किती पुल आहे ग्रॅव्हिटेशनल पुल, सो द वेट that is W is equal to M into G. So the mass of the sumo wrestler is 300 and acceleration due to gravity 9.8. So we can consider this as 10. So this is 300 Newton.
3000 Newton. So the earth is exerting on the sumo wrestler 3000 Newton.
The gravitational force, the force of attraction between both the sumo wrestlers is 24 micronewtons. म्हणजे ॲक्च्युअली त्या दोघांमधला जो ग्रॅव्हिटेशनल पुल आहे तो 24 मायक्रोन्यूटन इतका कमी आहे, पण अर्थ जे त्याला पुल करते ते आहे 3000 न्यूटन. सो सच इज द वास्ट डिफरन्स, अँड हेन्स वी कॅनॉट रिअलाइज द ग्रॅव्हिटेशनल पुल विच इज एक्झिस्टिंग बिटवीन द ऑब्जेक्ट्स ऑन द सरफेस ऑफ द अर्थ. आणि म्हणून हा जो ग्रॅव्हिटेशनल पुल आहे हा कुठे दिसतो? व्हेन the moon has mass, the earth has more mass, large mass. So the moon is attracted towards the earth, or moon is moving around the earth. So there is a gravitational pull between the earth and the moon, or there is a gravitational pull between the earth and the sun. So when the masses are more, the gravitational force is seen, and when the masses are very less and the distance is also very less, the gravitational force cannot be detected. So in our next lecture we would be discussing about the characteristics of this gravitational force. Thank you.